Alright guys, next we are going to study options Greeks. What are Greeks? Greeks are simply mathematical representation of the factors that affect the option price. From the previous tutorials, you might remember 3 factors that affect the option price. That's the price of the underlying, the time to expiration, and the implied volatility of the underlying. Now for our examples here, we'll assume the underlying is stock, but it's equally applies to literally every other underlying as well. Commodities, currencies, everything. So the first one we start with is delta. What is delta? Delta tells you how much the option price would change by if the underlying, aka our stock, increases by $1. All right. So let's say we have Apple at 99 and its price increases to $100. We want to know how much the $100 call will change in price. And that is defined by delta. So that would be the initial price of that $100 call plus delta multiplied by 1, which is the change in the price of the underlying. So you guys can see delta by itself has no unit. It's simply how much the option price would change if the underlying price changed by $1. It's that simple. So here you have an example with Apple, the one that I just mentioned. Try and understand this formula before you continue more. Now, call deltas. We know that the price of calls increase as the stock price increases. So if that's the case, then call deltas will always be positive. Their range will depend from 0 to 1 based on how far out the money they are. And that's about it. You can see here at the money, the delta would be around 0.5. Another way to look at delta is the probability that the option will be positive, profitable at expiration. When I don't say profitable, I would say it will have positive value. It will have some intrinsic value. So delta can be thought of as the probability that the option will have some intrinsic value at expiration, in which case you can see why at the money options would be around 0.5. Because there's a 50% chance that the option expires in the money. While if something is very far out the money, probability is low, and that's why the delta would be tending towards 0. If something is very in the money, the probability is very high that it will expire in the money at expiration, and delta is around 1. So that's another way to think about deltas, and that will help you understand how delta will move based on other factors like time to expiration and implied volatility. We'll cover that in this tutorial next. But first, let's discuss put deltas. We know that the price of puts goes down as the stock price increases. So the put deltas would be always negative. They will range from 0 to -1. At the money, puts would be somewhere near 0.5, and that's about it. So let's see how delta would be affected by time to expiration and implied volatility. So as I said, delta can also be alternatively thought of as the probability of the option expiring in the money. So as the option gets closer and closer to expiration, what happens would be the in the money deltas, they will move towards 1 because there's a higher chance of them expiring in the money. While the out the money deltas, right, out the money options, their deltas will move towards 0 because there's a higher chance that they would expire out the money. So as we get closer to expiration, the curve that we saw starts to flatten out more. The top of this curve around here will go towards 1. It will shift higher, and then the bottom will shift lower. What happens with implied volatility? With implied volatility, the curve gets flatter. And the reason for that is we said option delta is the probability of it expiring in the money at expiration. So if implied volatility is high, many of these out the money options also have a higher chance to expire in the money. The probability increases. Why? Because volatility is high. Maybe one event, one day could simply bring this out the money option in the money. So this curve will go higher because the probability of expiring in the money on expiration becomes higher. And this part of the curves becomes lower because these in the money options can just as easily go out the money because of the volatility. So that's how delta is affected by time to expiration and implied volatility. Now, putting it all together, should be obvious what delta is. Delta is simply how much the option price would move with the change in underlying price. And the other way to look at it is the probability of the option expiring in the money. If you start to pick up options that are too far out the money, or the probability of expiring in the money is very low, then there's a high chance your option value will go to 0. And that's just something to keep in mind as you take risky options positions. All right, that's it for delta. There's not much more to add. We will see later in other tutorial on how to use it. But for now, I simply wanted you to get an understanding for it. The next one we'll discuss is theta and then vega.